Hello everyone and welcome back to our Python coding series. I am Manish and I am thrilled to have you here with me today. If you haven't already, make sure to subscribe and hit that notification bell so you won't miss any of our exciting coding. As you can see from the video caption, today we are diving into the topic of Bitonic points. And we have to solve this in the time complexity of log n. The best way to do this is using binary search, as the time complexity of binary search algorithm is log n. In this problem, we will modify our binary search algorithm because our array may or may not be sorted in increasing or decreasing order, as you can see from the question description. Now, before we jump into the Bitonic point problem, let's quickly refresh our memory about the binary search algorithm. Binary search is a searching algorithm used on sorted arrays by repeatedly dividing the search interval in halves. We'll compare the middle element with the nearby elements, and if the middle element is greater than the adjoining elements, we'll return the middle element. If the condition is false, we'll check whether the middle element is greater than the right element. If it is greater, then the right side array is used for the next search and vice versa. The process is continued until the maximum value element is found. Let's take an example array of elements 1, 15, 25, 27, 42, 21, 17, 12 and 11. So there are a total of 9 elements. N is equals to 9 and the index of the last element will be n minus 1, that is 8. So I've defined three variables: the low, high and the middle. At first, we'll set the low as 0. High will be set as n minus 1. If I just write it down as here. In the first case will be 8. So our middle element, once we enter the loop is still low is less than our high. That is the end case. While. So our middle will be low plus high by 2, that is 4. So we'll check for three cases. If the first case will be if ARR of middle, that is 42, is greater than the ARR of middle plus 1, that is 25, which is correct, and ARR of 42, ARR of 4, that is 42, is greater than ARR of 4 minus 1, that is 3. Then ARR of 3 is 27. So 42 is greater than 27 and 42 is greater than 21. So in this case, we'll return the middle element, that is 42. Also, you can see that in this particular array, this 42 is the maximum value. Let's suppose we change our middle element value to, let's say, a value which is 22, such that the question description remains true. That is, first the elements are strictly increasing, and then from the fourth index it is strictly decreasing. In this case, again we'll start from the low as 0 and high as 8. The middle element will again be 4. So we'll check the first case. ARR of middle, that is 22, is greater than 21. This case is true, but this case is false. So we'll skip this case. The next case is ARR of mid, that is 22 is greater than 21. So this case is true. So what we do is we'll set high as the mid value. So now this high will become 4. Now the while loop will be checked again. In this still low is 0 and high is 4. So the condition remains true. So again the middle value will be 2. 4 by 2 is 2. So it will again go back to these conditions and check. So now our element, the middle element is ARR of 2, that is 25. So 25 is greater than 27, which is wrong. So this case is skipped. The second case is AR of mid, that is 25 is greater than 27. This case is also skipped. So it will go to the third case. AR of mid is greater than AR of mid minus 1, that is 15. So in this case, as you can see, we'll set our low as mid plus 1, that is 2 plus 1, that is 3. The the value of the variable high will still be 4. We'll check the condition again. 3 is less than 4. So the middle element will be 4 plus 3. So as we can see, there is a double bar. So 4 plus 3, 7. 7 by 2 is 3.5. But since we are using the integer value, so it will be 3. So now the middle. So if I erupt this part, make it more clear. So we'll check ARR of mid, that is 3. ARR of 3 is 27 is greater than 22 and 27 is greater than 25. So our value ARR of mid will be returned. So that's the whole algorithm we were trying to define to solve this question. Now we'll write the code itself. Let's just see. We'll define a function wherein we will pass two arguments, the array itself and the length of the array. So let's define the function. Define find maximum. Will pass two arguments, array and n. We'll set low as 0, and there's this beauty of Python wherein we can set two variables in the same line, that is n minus 1. Moving ahead, we'll write the while loop. While brackets are not required. While low is less than high, we'll find the middle element as low plus high by 2. Now if our ARR of mid plus 1 is greater than ARR of mid and ARR of mid minus 1 is greater than ARR of mid is greater than ARR of mid minus 1. Let's say we'll keep some spaces to make it more readable. So in this case, we'll return ARR of mid. Now if this case is false, so we'll check for another case. If ARR of mid is greater than ARR of mid plus 1. So in this case, our high will be mid value. Else, we'll just set low as mid plus 1. And then we'll return. If none of the cases are correct, we'll return the last value, because if we go on increasing, the last value will be the most greatest value. So let's evaluate this model. This function print maximum element in the array is, we'll call this function find maximum, and then we'll pass the array and the length. So suppose 9. So we'll pass the same elements 1, 15, 25, 27, 42, 21, 17, 12, 11. Let's try running this. Enter. So as we have seen, okay, so there's something wrong. Let me just check. Error of high, error of mid is so here's the problem. ARR of mid is greater than mid plus 1. As you can see, we have defined two cases: mid greater than mid plus 1 and mid is greater than mid minus 1. So we'll save it and we'll try running this again. Ignore this part. So we can see the maximum element in the array is 42. Let's try it changing it as 22, and then we'll run back again. So now the maximum element in the array is 27. That's it. That's a wrap for the today's video. We have successfully created a Python function to find the minimum and maximum element in an array. I hope you found this video helpful and informative. If you did, please give it a thumbs up. Share it with your fellow coding enthusiasts, and don't forget to subscribe for more exciting Python coding adventures. Thank you for tuning in, and I'll see you in the next video. Happy coding, everyone.